Today, we are diving deep into how life on Earth is actually powered. And we're going to look at our planet's ecosystems not just as, a bunch of plants and animals, but as these incredibly powerful, super complex, and surprisingly inefficient engines. So, let's just kick things off with a question. What could a massive, living, breathing forest possibly have in common with the metal engine humming under the hood of your car? I know it sounds a little strange, but the answer is way more profound than you might think. And it all comes down to energy. You see, at their most basic level, both of these systems are really just energy converters. An engine, right, it takes the chemical energy in gasoline and turns it into motion. Well, an ecosystem takes the energy from sunlight and uses it to sustain all the life within it. Both need fuel, and both have a primary job to do. And this simple comparison, it's the key to understanding two of the most fundamental laws of the entire universe.
Okay, let's start with the first rule of this natural engine, the rule of energy in. This whole thing is governed by a bedrock principle of physics, which is the first law of thermodynamics.
Now, the first law is it's beautifully simple. It basically says you can't make energy out of nothing, and you can't just make it disappear into thin air. All you can do is change its form. Think of it like money. You can change a $20 bill into 4 5s, but you still have 20 bucks. The total amount is always conserved.
And in nature's engine, we see these transformations happening literally everywhere. It all starts with sunlight. That's the ultimate fuel source. Plants, our producers, capture that light and transform it into chemical energy. That's photosynthesis. Then a herbivore comes along, munches on the plant, and transforms that chemical energy into energy for movement, for growth, and for body heat. And then, finally, a carnivore eats the herbivore, and that transformation just happens all over again. See? The energy is never actually lost. It's just getting passed along and changed.
But that brings us to a really crucial question. If energy is never destroyed, why do ecosystems need a constant supply of sunlight? Why can't they just recycle the same energy over and over again forever? Well, the answer lies in our second rule, the rule of energy out.
This is where the second law of thermodynamics crashes the party, and it's basically the universe's ultimate no free lunch policy. What it says is that every single time energy changes form, some of it is lost as low-quality, unusable heat. This process increases the overall disorder, or what scientists call entropy, of the system. Think of it like this. No engine, and I don't care if it's in a Ferrari or a living cell, is perfectly efficient.
And this is not just some abstract physics idea, it's a hard biological reality. Every time an animal breathes, or moves, or even just stays warm, it's releasing energy as heat out into the environment. That energy did its job, sure, but it can't be passed on to the next predator in the food chain. It's gone.
So, just how inefficient is nature's engine really? Well, scientists have a pretty simple rule of thumb that makes this whole concept incredibly clear.
10%. That's it. This one little number explains pretty much everything. It explains why there are way more plants than zebras, and way more zebras than lions. What this shows us is a massive, massive inefficiency at every single step. Of all the energy an organism takes in, only about 10% of it is actually stored in its body as biomass, ready to be eaten. The other 90%? Yeah, that's used up for its own life processes or just lost as heat. And what's really fascinating here is how this chart just visualizes that massive energy drop-off. So look, you can see the plants at the bottom. Let's say they start with 1,000 units of energy from the sun. Well, the herbivores that eat them only get to store about 100 of those units. And the carnivores that eat the herbivores, they're left with just 10. It's a pyramid, and it gets incredibly narrow incredibly fast. So this brings it all back home, and it really shows why that engine analogy works so well. An ecosystem, just like a car engine, needs constant fuel from an outside source, in this case, the sun. It is constantly losing energy as waste heat at every single stage. And here's the critical part. This inefficiency is what limits the entire system. It's the reason why food chains are usually only 3, maybe 4 or 5 levels long at the most. There simply isn't enough energy left to support another level on top.
Okay, so we've gotten through the physics of it all, but why does looking at nature as an engine actually matter to us? What's the big takeaway here?
It matters because it reveals the absolute non-negotiable importance of the base of the food chain. Those producers, the plants, the algae, they are the only entry point for energy into our entire living world. Full stop. It also shows us just how fragile the system really is. A problem at the bottom doesn't just affect the next level up, it sends shock waves all the way to the top, where that energy is already incredibly scarce. So, I'll leave you with this thought. Knowing that a whopping 90% of energy is lost at every single step of the food chain, well, it forces us to ask a really critical question. If this is how inefficient nature's engine is by its very design, how incredibly careful must we be to protect its fuel source and the producers that make all of this life possible in the first place?